Casual Friday.
Hello everybody, it is Mike Levin on Friday, April 2nd, 2021. And when last we left off, I was collecting data from Google Search Console. And I have changed the output, this very verbose output, now so that when I run it, it just prints dots or exclamation points, depending on whether it hit the API or not. A dot if it's cached, and an exclamation point if it hits the API. So, kernel, I'm tempted to go to run and do a up to current cell, but it's nicer to do restart kernel and run all cells. And you'll see the difference between a cached day, and it starts now at the oldest possible date and then goes to the newest, so that it always captures the oldest dates first. So you can see I hadn't run this in 2 days, so you've got dots that indicate cached. It has cached data for the day, so it skips the entire day. And for new days, this is, I suppose, yesterday's yesterday. It hits and gets all the rows up to 5,000 and then gets one more to make sure that it returns empty. That's why you see 2 exclamation points on these 2 days. And if I were to run this cell again, you would see it would just be the cached output for all those days, including the last 2. So that data feels somewhat inaccessible under most cases. You will recall that I am dropping all these things into my directories, which go GitHub and then repo name. We're doing SEOML right now. And then inside a cache folder, there's 2 different ways I do it. These are no longer applicable because they were as I was developing this system and I was using a date dependent cache. Now it's a single cache location, and so this gets just bigger and bigger as I collect more URL data from Google Search Console running. So it really is accessible. It is a SQLite database sitting there on the drive. However, I'm connecting to it through an API that is much more like a dict object. As soon as you have this file object from the context manager opening the SQLite dict API, cache location, that's where that path comes from, gives it a file name. Then every time I refer to it, I just plug a key in to that file handle and I get a response. And so that's how you use it as a dictionary object. So to get at some of that data, it occurred to me that I should just run it and then break out on the first row and say there's a variable named last. In this notebook-like environment, you will now have sitting around a variable named last that you can look at and inspect. And because I broke on the first row, this is going to be the first, let's see how it's going through. Yeah, it's just stepping through the keys, so whichever key came first. We could look at the key as well, because for I, comma, key, yeah, key will be in memory as well. So the GURL object that created this is that, and that is, of course, the pickled form of it. You can see the B there for binary before the open single parenthesis and the close single parenthesis. So I can use the unpkl function on that, and you can look at it in its normal state, and you can recognize those parameters, which I'm using now for both directly calling the API that fetches this data, right, and as keys in a database. So in these key value pairs of the dictionary-like object, I'm using this named tuple that can also be used to call the API. I'm using it as the key of the database. So I find that very clever. Anyway, we were looking at the last row, and this is a place where you can see list comprehensions will come in handy. Instead of looking at all that data, all you have to do is get a general idea of the shape, and you can see there's a key called rows, and that's where we begin. I already built the thing up here, but I am going to put a cell above it and start at the beginning. We know that the object is called last, and we know that there's a key named rows. So there's that object, rows. Now, that just went one level deeper into the last object, which, as you recall, it is a dictionary with keys. One of the keys is rows. So we're getting this sublist, row colon what? Well, row colon all these URLs. So that's what we're looking at here when I plug rows in as the key. See, that's the beginning of the list, and there's my list of dictionaries. So whenever you have a list, you remember, you have the ability to do list comprehensions. At first, if you just put the square brackets around it, you get an extra level of nesting. But for those people still trying to grok list comprehension, you give an extra level of list nesting, and then you do x for x in. You can use any arbitrary variable names here, but you can see that gets rid of that extra bit of nesting and now lets you do things here, such as, well, we've got another key value pair thing, keys, clicks, impressions, click-through rate, ratio, and position. These are all your Google Search Console metrics, which are very interesting and of use. However, in this case, I am really just interested in the URLs. I am getting like a sitemap. I'm emptying out a list of the URLs in the site. So in that case, I will reach into the object called keys, right? So we've got a list of URLs. That's list comprehension. That's the magic of list comprehension, how it just kind of reaches in and does that. However, you can see it's still a nested list, and that is not necessary. We want the first item in that list, so we just put an arbitrary key for the 0 indexed item. Nope, that's not it at all. Oh, these are individual lists. It's not a nested list. It's a list of little lists. So that key index 0 goes on the sub item, not the outer item. And there you have it. Here is a list of URLs. Now, being a list of URLs as it is, one of the interesting things to do is to check its length. How many items are in there? There are 97 items in there. Remember that number 97, because I'm going to get rid of that length function for a second and change it from list comprehension to set comprehension, which has natural deduping. It'll lose any order that you might want to preserve there, but it now is a set, which means no dedupe, no duplicates. So now if we did a length of that, is it 97? Yeah, it's 97. So it actually was naturally deduped when we emptied out the contents. Oh, well, that was just that single day, right? So the thing is, I broke out and I'm showing last. We're going to be appending lists together. We're going to be adding lists together. And you can see that reflected a couple steps ahead here. You can see I'm basically reproducing this. I don't need that anymore. I showed you the creation of that. Now we're going to transition from this idea, doing it for a single key name value pair found in the database, to doing it for everything in the database. And I could just turn this from raw back into code and show it to you, but I'm going to reproduce the concept here. So sets can be added together with this dot update. So if I were to have a set of 1, 2, 3, oh, Yep, double parentheses because it's got to be like a fed in as something, so might as well feed it in as a tuple. And you added that to set 2, 3, 4. Oh, you can't just add set and set, so you can update one set with the other. And this has the same result as adding them. So I can say result equals, oh yeah, result equals, and let's take a look at that result. Okay, so it's because it's in memory. So what I really want to do is S1 for set 1, and this is S2 for set 2. S1.update S2 S1. There you go. Instead of just being 1, 2, 3, it's like it got added to this S2, and the 4 got in because that's the non-overlapping member that's in common to both. So I am going to create an initial set, which is all URLs equals a set object. And then we use the context manager with, and I've abbreviated it now to just SQLdict because it's so much easier for me to think of the SQLdict object than the upper lowercase SQLdict-lite. So I kind of renamed it on the import. Imports SQLite. Yeah, there it is. So I, from SQLite dict, import SQLite dict as SQLdict, right? So this is my abbreviation now because already there's an inconsistency, all lowercase one word, Pascal case, and so I'm going to go for single instance lowercase non-snake. Just appended together. I find that to be a real nice convenience in situations like this because it's mostly going to be just me using it, right? So you see me using it here, and so again I'm using it in this new command I'm stringing together, which is going to load it, and I'll just copy this from here, right? Because no reason to retype that. So it's the context manager opening this file, right? And giving it a handle, so it's now being treated as a dictionary. And I'm jumping right into here. I can just show the first one, so I can you can always break. Well, this doesn't even need a break. It's just the context manager and insert it. You just need a single key. Oh yeah, okay. Even just to get a single key is a little bit challenging. So to step through the keys, it's not challenging to step through keys. You can go for key in DB, that's the simpler form, and print key, and that'll just show you there are all those pickled forms of the keys, stepping through that one by one. So I suppose I can unpickle it just to show you it. There's the original API calls that caused the data to be stored, and you'll always see it's just a row 1 and essentially a row 2 because the start row is 5001, which is always going to be empty. So I could show you that when you're doing this sort of thing, you can plug that key. It doesn't have to be unpickled to be plugged back into the DB. So DB plugging in the key represents a fairly large chunk of data. So I can just print the length of it instead of the data it contains. And you can see the length of it alternates between 2 and 1. 2 means there's a rows key in there, and 1 means it's an empty result set essentially. So you're sitting on the data that can be fed into this, because remember, last was standing for a single instance of the data, and now a single instance of that data is db key. So what I do up there is I say rec for record equals db key. Now you're sitting on a database record instead of having to use this more wordy and might forget it syntax. But REC stands for a single record. And yeah, I could print the length of that there. It would be the exact same thing, length of REC. Get the same 2's and 1's. But the important thing is that you've got a record there that you can manipulate as part of this function I just showed you us writing. And what does REC take the place of? That's right, the word last, because that's a single record, and that last stood for the last record. And the X for X in record rows is correct. Now you'll see I have just one more piece of logic here. This really shouldn't be done unless there is rows in record. So if rows in record, then pull that function, and you'll remember I was telling you about adding it to a list, the list name .update, and the curly brackets here is set comprehension, so it's naturally deduping. So there we have it. I just recreated the function, and there's really no output. I'll just throw in a gratuitous print a period with end equals nothing. And that's a nice trick to just show an iteration, a period for each iteration through the loop without killing your Jupyter Notebooks or Labs instance. And now I can just take that all URLs, print it here, and it's going to be a list of all the URLs from my website. And I can get the length of that. I know there's no duplicates because the type of it, because of the way I created it, is a set. So there's no duplicates. They're all unique values. And the length of that, to show me how many URLs, are 735. So I have 735 URLs in mikelev.in that have some search life to it that I can perhaps think about, preserving the traffic from. I've got a few pagination issues in there. Pagination has somewhat gone out of style. However, I've got a lot of very good keyworded, potentially timeless, although there are dates. You can see my blog goes back to 2005 here, talking about OpenReco and the rise of AJAX programming technique. Wow, how the web has changed through the years. I was writing through 2009, 2010. I start getting found on things about QEMU and serial port putty things, and Python programming advantages there through 2011. I had one of the top articles out there on why Python was such a great programming language, and here we are in 2021, 10 years later, and I have no more real content to speak of. I stopped writing around 2011, 12, 13. Kid happened. It was a different life, and so let's see what I can do about asset preservation. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.